Earlier this year, Dr. Tzvi Tavor has won the award for contribution to society. He won this award for his disruptive invention of coating for domestic solar water heaters. And since the 50s, we can all take showers in hot water. And also, Israel was the leading country in solar energy for several years to come. Hello, my name is Eran Maimon. I am the CTO of Solarpaint, and we will be disruptive. Now, we all know the amazing investment in the solar arena in the past decade, with gigawatts on gigawatts of installed capacity in utility-scale power plants and on rooftop installation as well. However, in recent years, the innovation in this field is quite stagnant, and the small improvements that are being made do not address several major issues that are a problem in the current technologies. First is the huge spaces that are needed for these utility scale plants. The second is the high cost of the installation, and third, the inadequacy of a lot of space of surfaces to accommodate these bulky solar panels. But imagine, what if we could use any surface that is used for other purposes and transform it into a functional solar harvesting system? Simply and cheaply, just by painting it. This concept we call Solarpaint. You just paint it, connect it, and that's it. Imagine the impact. Imagine the potential for that. Rooftops, walls, roads, actually any surface that is just lying down in the sun and warms up. We are making this vision a reality. For this, we've gathered a very strong and interdisciplinary team with experts in solar energy, in business development, chemistry, and nanotechnology. We've established a company and we got seed funding. Now we're working on R&D in the Technion in a laboratory there. And we're making there our low-cost Solarpaint prototype. This prototype is based on oxides, which are cheap and stable. You know, rust cannot rust. And actually, it should hold around 10 years. And with the current materials that we have chosen, we should expect efficiencies of around 8%. This is all possible through novel technologies that are now possible, that have been developed in the past decade in laboratories around the world, which enable very precise control of both geometry and morphology of the nanoparticles. And what's best about it is that it's made by wet chemistry techniques, which are highly compatible with current traditional paint manufacturing techniques. That can make our R&D cycles cheaper and also make the scale-up very easy. So how does it work? We take our proprietary selective electrode mesh and apply it on our surface. This is where we take out the different charges. Over this net, we paint our oxide-based paint. And once it's cured, all you have to do is connect it to the peripherals, to the inverters, and whatnot. Depends on grid, off grid, and voila. We've applied for patents for this technology, and we actually, for this application, for buildings, we get an ROI of around 3 years. But since you're going to paint your house anyway, and probably pay someone to do it, then the ROI drops down to 1.7 years. Our long-term goal is to go and apply our paint on roads. If you consider 80,000 square kilometers of roads, of highways, only in the US mainland, and you multiply that by a modest 5% efficiency paint, you get 8,000 terawatt hours per year. which is twice the amount of energy that's produced today in the US as a whole.
3,
Now that's
2,
an impact.
1.
Thank you very much.
Thank you.